interesting problem and very conceptual problem. Now, what is the problem? When this 4m is released, it will go down and this will go up. Now, the moment it will go down on this ground, this particular thread will be loose. Let me draw it. See, this is the initial position of this mass, right? If it is going down and touching the ground, then this body by inertia is still going up. So this is going up, this end is going up, but this particular part is not moving because it's touching the ground. So this thread will be eventually loose, right? The moment it will be loose, the tension will be equal to 0, because we know in a thread, if the tension is if the thread is tight, that there will be a tension. If the thread is loose, the tension will be 0. Please remember this. Will come back to this concept. Okay, this is a very interesting concept. Okay, if two parts of a thread is moving in different velocities or accelerations, that means the thread is bound to be loose, and in that case the thread will be, the tension in the thread will be 0, because let me draw it again. This is a thread. If this part is going with V1 and this part is going with V2, the different velocities, the tension will be 0. Okay, alright. So let me first draw before touching. Before touching. Just a moment, please. Okay. Oops. Just a goof up. Hold on. Oops, sorry about that. Anyway, so before touching, this body will have some acceleration and this body will have some acceleration. Let me find out what are those accelerations. Okay, so obviously we'll start with this thread. The tension is T, this tension is T, this tension is T, and this tension is 2T. We have solved it many times. And if this body, the 4m, is moving down by acceleration A, this m will go up by acceleration of 2a. Why? Because again, by constant relationship, still we can, because if this part is going up down by x, that means there is total gain in this loop is 2x. So this part will go up by how much? 2x, because the length of this thread is constant. So if this body is going down by a, acceleration a, this body will go up by acceleration of 2a. So let us draw the free body of this. Okay, free body of 4m. In downward there is 4mg, in upward there is 2t, equal to 4 ma. This is the first equation. What about this? This body is going up by acceleration of 2a. So t minus mg equal to 2 ma. This is my second equation. Okay, let me solve it. I'll multiply it by 2, so this will become 4. I'll add it. So what I'll get? 2 mg equal to how much? 8 ma. So essentially I'm getting a equal to how much? A is g by 4. So this is my equation. Okay, so this body is going up. Look at this body. This body is going up by acceleration of 2a. And when this body is go down by h, this body will go up by 2h, right? As we have discussed. After attending this 2h distance, what will happen? The thread will be loose and the tension will be 0. Then the body will have a upward velocity. I have to find out that velocity, and downward acceleration, what is g, because there is no tension, only the mg is working. In other words, we call it free fall, right? when there is only accelerations of g downward, but it will not fall because the velocity and the acceleration are working in different directions. So it will decelerate to attain some more height till the velocity is equal to 0. Okay, again we are coming back to that. Okay, so let me first find out what is the velocity when it's attending 2h, distance 2h. Okay, now we know the formula v square equal to u square plus 2as. What is v square? I want to find out. What is u square? 0. It started with 0. And what is 2 into acceleration? What is the acceleration of this body? 2a. That means 2g by 4. That means g by 2. Okay. Into what is the height attained by this? 2h. Are you getting it? Okay. So the velocity square at this point after attaining height 2h, when this body is just going down by h, is how much? It's 2gh. Now come to the second part. We are starting our clock again. So the velocity over here is v and the deceleration is g. So we'll use this formula again. Now it will go further height, let's say h, and stop. Stop means v square equal to 0. What is the value of u square? U square will take 2gh, because this is the new velocity. I mean, we are starting, this is the starting velocity because we are starting our watch from here. So v square is how much? 2gh. Okay, minus, why minus? Because it's deceleration, 2g capital H. Suppose it's going up another capital Hi. So essentially we are getting h equal to h. So it will go further height of h. So what is the total height attained by this body? This body, the first is going 2h and then is going another h. So the total height it will go before stopping is 3h. Pretty interesting problem. If you have any problem in understanding this problem, please contact me.